In order to turn Echo from this into this, it needed to inflate itself in space. Instead of carrying its own air, the balloon had small canisters of benzoic acid, a special powder that turns straight from a solid into a gas when exposed to heat. And so, when the balloon was released into space, the heat from the sun would quickly turn it into gas, causing it to expand inside the balloon. In just a matter of seconds, this enormous balloon would be fully inflated. But having such a massive object in space made it a target for micrometeorites. To combat any small punctures to its skin, Echo 1 carried extra supplies of benzoic acid that could be released to maintain the balloon's pressure. Echo 2, on the other hand, had a better solution. Its skin was also made of mylar, but it was sandwiched between two sheets of aluminum foil. When the balloon was pressurized, the foil would get stretched, causing it to stiffen up and harden in place. This made the balloon rigid. Even if micrometeorites hit the balloon, it would maintain its shape. Of course, these giant shiny balloons ended up being extremely visible. For an entire decade, they were some of the brightest objects in the night sky, even brighter than the North Star. But this brightness was actually a key feature. In order to actually send and receive signals, the ground stations had to be able to track and lock onto the balloon as it moved across the sky. And so, the easiest way was to simply point the antenna dish directly at the balloon when it was visible. Of course, this was only possible when the balloon happened to be over that part of the Earth, and only during twilight hours when the sun was illuminating the balloons. If the balloons couldn't be seen with the naked eye, they could rely on NASA's tracking network, which did its best to predict the orbits of satellites. On Echo 2, they included a tracking beacon, which sent out a pulse and made the balloon much easier to track during the day. Most of Echo's communication was done between purpose-built ground stations in California and New Jersey. But Project Echo was a global experiment. Thanks to its polar orbit, the balloons passed over every part of the world, allowing transmissions to be done by anyone that had the equipment. Transmissions were even done between the US and the Soviet Union, who nicknamed the balloon the Friendly Sputnik. But the balloons weren't just useful for sending signals around the world. They were also used to accurately measure the size and shape of Earth. At the time, our most accurate measurements relied on star triangulation, which meant that the actual distances between continents and cities could be off by over 100 kilometers. And so scientists used Echo to map the exact location of various points all around Earth. First, they measured the signal travel time from two different locations, which would give them the distance to Echo. Then, by measuring the angle that Echo appeared in the sky, the scientists could form a triangle. With this, the distance between both points could be calculated to within a few meters. This made our measurements of the Earth around 10 times more accurate. But the science didn't stop there with Echo. After all, NASA was only a couple years old at the time, and very little was known about the long-term effects that satellites would experience in space. One of the biggest unknowns was atmospheric drag. Even at an altitude of 1,500 kilometers, there are tiny traces of atmosphere that will slow down objects in orbit. And with such a large surface area, these balloons felt the effect more than any other satellite. Thanks to Echo 1, NASA were able to track how its orbit changed over several years. As it turned out, it changed a lot. Surprisingly, atmospheric drag had nothing to do with this. Instead, the solar wind, which radiates out from the sun, was pushing Echo 1 towards Earth. These two balloons continued to work perfectly throughout the 60s, and they proved that a global communication system in space was a good idea. During their time in space, these iconic balloons taught NASA more than they could ever have imagined. The receiver that was used to detect Echo's signal went on to discover the Big Bang. The materials developed for Echo are still used in spacecraft to this day. Although these types of satellites never caught on, their legacy as the first leap into space communications will live on forever, and Echo 1 and 2 will go down as the most beautiful satellites ever made.